Well, hello guys, here Mr. G with another question for the grade 12. This is question 4 from this informal test we're practicing about electric circuit. But for this question, you need a pen, you need a book, you need to answer the question, guys. So try to answer the question and take some notes. The question say, in the circuit diagram below, a battery of a known EMF and an internal resistance of 0,5. So in this case, we don't know the EMF. Okay, and I want you to point out before we carry on, this voltmeter here is not reading the EMF because the circuit is working as it look in the picture. So this one is actually reading the external voltage. Okay, so now we carry on reading. It's connected to two resistors, 4 and 8 ohm. This one is quite simple. You can see the resistors are connected in series. Define EMF is a tricky definition because it's been asked a lot and it's not in the examination guideline, guys, that you have with you. And this definition is the maximum work done by the battery per unit charge. Remember, potential difference, guys. Potential difference is equal to work done per unit charge. This is potential difference, is the definition of potential difference, and is a formula, guys. It's very simple. But now we're talking about the EMF, and the EMF is just the only difference from here is that it's the maximum work done, and it's really simple. You will get 2 marks if you have this definition correct. Now let's maybe give us marks. So if you answer the question, you can actually mark yourself. When the switch S is closed, voltmeter V2 read 3,2 volts. We already spoke about voltmeter 1, but voltmeter 2 here down, which is reading just the 4, is going to be equal to 3,2. So let's write it maybe there just for us to remember. V2 is equal to 3,2 volts. And then they say calculate the reading of the ammeter and the EMF. Okay, so it's fine. Let's see, according to what we have, what can we calculate here. Okay, quite simple, guys. If you calculate the current through the 4 ohm resistor, you have the current of the circuit because the current stays the same. So very simple. Let's solve that one first of all. This is question 4.2.1 when we're calculating the current. Now guys, the formula that we have in the formula sheet, remember, I don't like to write the formula in a different way. This one, still the note from last time, is this one here. So here we have that the resistance is equal to potential difference divided by current. We're going to work for the 4 ohm resistor, né? So the resistance is 4 and this is equal to potential difference, which is 3,2, guys, divided by the current, which is what we are looking for. When you rearrange this one, be careful. I see a lot of mistakes kids used to make here. Current is equal to, let's move it here, let's not do it too close there. This one is current is going to be equal to 3,2 divided by 4. Therefore, the current that is going to be throughout the whole circuit, guys, is going to be equal to 0,8 amperes. There we go. This is the current throughout the entire circuit. That is the current through the entire circuit. And then they ask us for the EMF of the battery. Guys, we have the current. We can get the external resistance. It's quite simple because the resistors are connected in series. So let's quickly calculate it here. We are going to need it. External resistance is going to be equal to 4 plus 8. Why is that so? Because the external of the two resistors are connected in series, guys. This one is the 412 ohm. That is the external resistance. So question 4.2.2, they ask us to calculate the EMF of the battery. What formula can we use? We can use Ohm's law for the whole circuit. It is here. Once more, we can use it. We did use it in previous questions. So that is what we are going to use, and we're going to do it on this left hand side here. Okay, so EMF is equal to current bracket external resistance plus internal resistance. Quite simple because we have everything here. The current was just calculated and is 0,8. The external resistance we calculated and is 12, and the internal resistance was given to us and is 0,5 ohm. Guys, simple calculation. When you do that calculation, you will get 10 volts. So the EMF of the battery is 10 volts. Quite simple. And let's write here, this one is question 4.2.2. There we go. So the final question now says the battery become heated when voltmeter V1 is replaced by a connecting wire. Explain this observation. Okay, so let's see what is happening here. Now they are coming here, and somebody substitute this V1 and instead connect a conducting wire from this point all the way a conducting wire there up until that point. Now, what is that? That is something we call short circuit. That one, it will be a short circuit. Okay, that is a short circuit. And now if you connect that short circuit, the resistance decrease. There is not resistance in that wire. Remember, wires have a negligible resistance, so the total resistance of the circuit will be decreased, and that is the first important note there. First of all is to write that there is a short circuit. There is a short circuit. That is important to know. Okay, and then it means that the total resistance decreases. Total resistance decreases. And then because current is inversely proportional to the resistance, remember that resistance is equal to V over I. You can see that current is inversely proportional to resistance. Current is inversely proportional to resistance. Then the current is very high. Okay, why is very high? Because the resistance decreases. Okay, resistance decreases, then the current is very high because the current is inversely proportional to resistance. All this one we have to say. And then to finish here, we have to say that higher current produces more heat. And then we are done. Higher current produces more heat. Higher current produces more heat. Guys, this is the end of this question. Thank you for watching. Thumb up, don't be stingy. Thumb up if you think it helped. And then subscribe for the channel. I'll see you next time. Mr. G here.